Myself, Ram Kumar. I am from Department of Computer Science Engineering in Multech Engineering College. Today, I am going to explain about our project Deepfake Detection through Deep Learning using restnext and lstm. My teammates are Dinesh Kumar and Satish Kumar. Let's move on to our outline of our presentation. So, a problem statement, and then abstract and the introduction, and we will explain existing system, proposed systems, then move on to architecture diagram and software and hardware requirement, and finish with references. Problem statement. The major concern of current deepfake detection system is it not able to identify temporal context between the two frames. The frame-based limitation, independent frame evolution, temporal seamless. All this three comes to say that it cannot identify or it cannot store a relationship between the two frames. So that you can ask what maybe the disadvantage of not storing a temporal context. If it doesn't store the temporal context image, we cannot able to identify the lip sync movements and head jerks in the videos. So we are processing with advanced model such as restnext CN and lstm models. Here we restnext model is used to process an image, and lstm is used to store a temporal context information about an image. The major advantage is restnext uses to process and give the information to lstm. The lstm store its as much as so that if in the future if we in a processor need any information about the image, it can collect from LSTMs and can be reprocessed. Introductions. First of all, you understand what is deepfake. Deepfake is nothing but AI generated videos or modified videos based upon the deep learnings or using the deep learning techniques. Modifying a videos by an AI, and we cannot able to identify the image or videos are real or fake. We need any tool to identify the videos are real and or fake, so that we need a reliable detection systems. So we are proposing our model with ResNext and LSTMs, which are more reliable than existing systems. How we will tell existing systems, as I said before, it uses your CNN or such as exception network. Um, First of all, I explained the existing system with a simple example. If you given a video, the videos is divided to each and every frames, and each and every frames are processed separately. So you can think each and image are processed separately, so it will be more accuracy. But the major concern about this model is it take a lot of time. You can't imagine, or if you were given a 10 minutes videos, it divide it each and every frames and it process the individual frames separately. It takes a lot of time, a lot. And the major disadvantage of this, it's not identify the temporal context, as I said before, and inconsistent lip movement and doesn't sync with audios or unnatural transition didn't identified. Then our proposed system is using ResNext and CNN and LSTMs. ResNext CNN is used to process an image. The major advantage of ResNext CNN is it processes more accurately, as well as the major advantage is it is a parallelism. If you given a hundred frames, it process each and every frames are parallels, so that it take a less time, as well as it give the LSTMs. Why we chooses LSTMs is because we can avoid gradient problems such as losing of an informations for in short periods. We can eradicate this eradicate like the problems using LSTMs, so that all the disadvantages are eradicated in proposed systems. The comparison tables in the comparison system, the major we want to see that more parallelism and it's less parallelism. So faster training and interface may be a slower and detailed task, as well as ResNet is advanced of a ResNet, so that it will be more accurate than a ResNet. This is our architecture diagram. First of all, we upload a real-time data videos. It given to a pre-processing. In pre-processing, the videos are split into frames, and from each and every frames it detect the face, and the detected face are cropped into new videos and it given to a data set, and the data sets are used to train and test, and given to a data loader to load the data into a models, and after the model is trained, we use model evaluation to identify how the model is performed, and it is saved into a load trained models, so that if a new user came, they don't want to move on to all these steps. They directly upload a videos and pre-process and give into a trained models and identify which is real or fake. Okay, this is our architecture. Let's move on to our list of modules we used in this projects are video upload modules, deepfake data preprocessor, and deepfake detection pipeline using restnext lstms, train and test model, and model evaluation finally. Video upload modules. Here, we facilitate user-friendly video uploading, a real-time video uploading, initiating deepfake detection process with accurate input configurations. Here, we mentioned a sequence length. It is nothing but if you given a 20 or 40 or 60 or 100, up to 100, we have been given as a for an input to the users. Here, the sequence length 20. What it means nothing but if given a 20 sequence length, it divide the frame count, like if you given a 20-second videos, we fix it with the duration of 20 second. In 20 second, how much frame you want. If you given a 20, it divides the 20 frames from the 20-second videos. Likewise, if you given a more or 20, 10 minutes videos, and given a 20, it will be faster. But if you given a 100 for 10 minutes video, it take a lot of time, but it will be more accurate. Based upon the user interest, they can be changed their frame counter. Then about the data preprocessing modules, in our data preprocessing modules, we upload input videos. The input videos are divided into each and every frames, and each and every frame they made face or cropped, and it made a new videos, and the cropped videos is uploaded to our modules. The ResNext process the image and stored in LSTMs, and it used to retrieve and process, and I finally identify real or fake. This example of testing training modules. Then model evaluations. We use as a metrics to evaluate our models are accuracy, precision, recall, F1 scores. The ResNext and LSTM model push our percentage, boosting F1 score from 79.21% to 91.84%, and face cropping and processing with our data preprocessing techniques. We used to increase our detection accuracies from 82.45 to 93.67%. This is our sample output homepage. And if you this is our test case. If you're pressing upload button without selecting a videos, there will be a prompt, please select a file. So it's like a test case and uploading a real videos and identify real videos which is a fake or not. This is our hardware and software requirements. Maybe more required graphics cards as it's processing in deep learning. Our software specifications are minimal software specifications. We use the programming language Python and Cloud Platform to store our model. OpenCV libraries and face recognitions are used. This is our reference. Thank you.